Hello, this is Mr. Stansbury. I'm going to take you through the notes on instantaneous rate of change. After this, you should be able to say, I understand what the instantaneous rate of change is and how to find it given a graph or data points. Okay, so first things first, the instantaneous rate of change is the change in the rate at a particular instant. Okay, so I know that's kind of a weird concept. Let me throw this at you right here. Here's an example of a velocity time graph. It's a car journey. So basically here you are, you're starting out, and then this is time here, and this is velocity, right? Meters per second, so your speed. Okay, so right now as you pop in the car, and then let's just say you're on the street already, and you start, here you are accelerating. So you're going, the steeper this curve is, the faster you're going. So like about right in here where it's fairly flat, it's a constant speed, and so constant acceleration. So you're increasing here. So this here, it's getting faster and faster, increasing acceleration. Constant acceleration here where it's a straight line. And then as that line starts to flatten out here, this is the acceleration. You're still going faster, but you're decreasing. You're going faster and faster here, but you're not speeding up as quickly. Okay, so you're speeding up quickly here, you're accelerating here, but at a constant acceleration. Now you're kind of slowing down your acceleration. Here's your your max speed right here, your cruising speed, your constant velocity. And now you're increasing your deceleration, which is kind of a strange way to call that. So basically it means you're decelerating here. So you're actually slowing down your speed. Okay. And then this is a constant deceleration. So you're continuing that. So you're kind of slowly slowing down here at first. Now you're slowing down a little bit faster. And then you're decreasing your, increasing your deceleration even faster down here. So you're coming, like pulling up to a stop sign, come up, and then you're stop, because now your speed here is flatlined here. Okay, so again, this is your acceleration piece to that. So hopefully that makes a little bit of sense. Another way to look at that is this here. So this white line here, just think of that as a graph here, and I put several different lines on here. From A to B is a chord. Like on the last section that we just did, we were trying to find the slope between these 2 points given, like say A and B. So we were actually finding the slope of this chord here. So now what's a little bit different about instantaneous rate of change is you're finding what the slope is at one point on a graph, which is really kind of strange, I know. But so basically what we do is if we're finding the instantaneous rate of change here at A, we're going to draw what we call a tangent to this point. It's basically you've got this line that hits just at that one curve here. It doesn't cross through here or over there. It just touches it right there. Another way to look at this, like a good real world example of a tangent, is if you take a ball and you rest it on a table, where the ball touches that table, that's the tangent point. Okay? So what we're doing now, if we're trying to find instantaneous rate of change, we're trying to find what the slope of this line is right here, because that would be the rate of change right at that point. And if we're going to try to find the rate of change here at B, we would draw another tangent line that just hits B and nowhere else. Looks something like that. Okay, so I'll throw this at you as well. I think this will help it make a little bit more sense. Example 2, use the tangents drawn to find the instantaneous rate of change in y equals f of x. So this pink thing here is y equals f of x. Okay, and then we're going to draw that instantaneous rate of change at A, B, and C. So here's point A. So I actually already drew the line for you. So all we're doing right here is just trying to find what the slope of that line is right at that tangent point. Okay, so the tangent line is the flat line here, and this is called the point of tangency. So right where it rests, right on that point where it only hits right there. Okay, so hopefully you can look at that and say, hey, the slope of that thing is simply 0, right? For B, right down there, and that, notice that this is a maximum. This is a maximum. It's important. And this down here is a minimum, and B is also at 0. This is a minimum. At a maximum or a minimum, the rates of change, the slopes of these tangents are always going to be 0. Okay? And these are also called, and we'll talk about this a little bit more later, these are called turning points. And I think of it as when it turns into going up to now it's going back down. And those are always going to have tangent lines of 0. Okay? And then, say for point C here, this has obviously got some kind of slope on it. So what I like to do on these to figure out what the slope is I'm going to find a couple of nice little points. So like this right here, I know that point is at 4, 6. And I try to find one down on this side too. And look, here's another really nice point right there. That's at 2, 2. Okay, so now what I want to do is just find the slope between 4, 6 and 2, 2, right? So 4, 6, doesn't matter which one we put first. So we do 2. Remember, the slope is y2 minus y1, so 2 minus 6 over x2 minus x1. And that's over 2 minus 4. So that gives us negative 4 over negative 2, which simply gives us a slope of 2 for this one here. Okay, so let's did everything else in blue, so let's put this one in blue as well. Okay, so again, important, the slope of a line, in case you forgot, slope is y2 minus y1 over x2 minus x1. I just always do this here. I actually learned this from my algebra teacher long time ago. I'm going to take this 2 here, always, because officially this is x1, y1, x2, y2. So I always start with the very last number there, 2, and I subtract the other y, y2 minus y1, and then I put it over the second x value, x2, 2 minus 4. And that's where this all came from. Okay? Okay, one last example, but before we do that, let's take a quick comedy break.
So I walked up to the mom and I asked her, how old is the little man? That's all I said to her. Her reply to me was, in a couple of days, he'll be 106 weeks. Are you mad at me? I don't have a calculator on me. I look over at little man, he's holding up 2 fingers like this ain't the first time she's done this. I'm 2. Like he talks good.
All right. Here we go. Last example here. Example 3, Spike the Narwhal does a 100-foot dive off of a cliff. There's Spike diving off the cliff. Don't worry, Spike was not injured during this example here. The graph displays Spike's distance from the water and the time since takeoff. So here's the time, and here's the height in feet above the water. Okay? So estimate, key word in here, estimate, does not mean calculate. Estimate Spike's instantaneous speed at 2 seconds. So at 2, I'm going to go up here, right there. And then that means what I need to do is I need to figure out roughly what the slope of that line is, that slope of that tangent line right there is, right? So this is going to be a little tricky because you got to go through and you got to draw yourself a nice straight line that goes just through that point. Not super happy with that one. Let's try that. That one looks maybe a little bit better. And I'm going to try to draw as long of a line as I can to give me as many options for points as I can possibly get. Okay? So that looks like that's a pretty decent tangent line. Doesn't quite cross right here. Looks like it's a little up above, and each of these is just 5. So let's call that, and it's at 1. Let's call that at 1, 101. Okay, because again, we're just estimating. We don't know exactly. And then we're going to look for another nice intersection line here, which of course there aren't any nice ones. So how about this? Let's look at this 4 right here. It's just barely up above that line as well. So let's call that 41 and 4, or 4 and 41, because x comes first, right? So then if we are going to figure out the slope of that, we're going to just do 1, 101. Oops. and then 441. And it doesn't matter which one you do first, as long as you keep both of them in the same spot when you're subtracting here. So we do 41 minus 101 over 4 minus 1. So that gives us what? Negative 60 over 3. Gives us about negative, 20. Negative 60 over 3 is about negative 20 for the slope there. So that means the instantaneous speed at that there is that Spike the narwhal is at negative 20, getting closer and closer to the water, 20 feet per second at that point. Okay? Okay. And then at 4 seconds, let's try that with a different color. Let's try that maybe in green, I suppose. 4 seconds, that's right here. I don't like green. Let's try purple. I think that'll stand out a little bit more. Ooh, except for not against that line. Yeah, good enough. You guys get the idea. All right, so then we try to draw a nice little tangent line right off of that one. That looks pretty decent. And we try to find a couple of nice intersection points. Again, not great ones. This one here looks like it's about at 2.5 and 81. Ew, I really don't want to do a half point. Let's do this instead. Since we're just estimating, let's do this one up here instead. So that one up there is at what? Another 101. Oops, except for I got to put the X in first. Sorry. So that is 2 and 101. And then try to find another one, hopefully on this other side over here. Let's try this point right. So it looks like it's a little bit below, but it's pretty close. Oh, that's 4.5. Let's do, you know what, we're going to have to go with that one. So 4.5. And a little bit below 5. Let's go with about 4. Again, we're just estimating, so we're good enough. Okay? So then what we're going to do there is we're going to have it that. So we'll set these 2 points up over here. 4 minus 101 over 4.5 minus 2. All right, so that gives us what? Negative 97 over 2.5. I'm going to use my calculator for this one. Okay, so negative 97 divided by 2.5 gives us negative 38.8. So about negative 38.8. And really we should be putting our labels on this, right? And that is going to be, it's rise over run, so it's going to be feet per second. Okay, same thing with this one over here. This should be negative 20 feet per second. Okay, so as you can tell, as they're getting farther and farther along, Spike the narwhal is gaining speed down here, right? Okay, and then last one here for this piece up here is, let's see, Spike's instantaneous read speed at 0 seconds. That's right here, right? So we make ourselves a nice flat line up here. And guess what that's going to be? That's going to be 0. It's not changing at all because that's right before, like right as Spike is getting ready to jump. Okay? Okay. And then describe what happens to Spike's speed over time. The longer Spike has been falling, heading towards the water, the faster he goes, and up until he gets to terminal velocity, right? So his speed continues to get higher and higher. Okay? All right, that's all we have for instantaneous rate of change. If you have any questions, please feel free to ask in class. Thanks.